All right, Ex7B, let's recap. I gave you last session some things to read about the parameters. So A, H, and K, I taught you to memorize what they do. I haven't explained why it works. So you're just going to have to trust me that it does work. Let's recap. The easiest one to remember is K. What does K do to this parabolic equation? Yes, Andrea? Very good. And you know, when does it go up and when does it go down? How do you know?
Positive and negative.
Very good. So which one's which?
Positive is up and negative is down.
Beautiful. So when K is a positive value, it will shift the graph or the turning point. That's the easiest way to sort of identify where the graph is. But use the turning point of your x squared graph. So let's say this is your typical x squared graph. Origin or turning point is at 0, 0. Wherever that 0, 0 is now, that will determine, K will determine the height or the Y values for it. Okay? Positive is up, negative is down. Very good. Next easiest one is H, or notice where I've drawn the brackets. How do you know what does H do? Can I please have Jaden? What does X plus H do again? It moves left or right. That is correct. But how do we do it again? I gave you a very specific technique and only I teach it. How do you do it? I want someone new. Let's go with Emma.
You do x plus h and you let that equal 0 and you solve for x.
Beautiful. So it's whatever you're squaring. So don't put the square in the calculation, okay? It's what you're squaring. So whatever in the quadratic equation, what are you squaring in this case? It's the x plus h. Let that equal to 0, solve for x. If x is positive, then it will move to the right. Very good. So positive is right. If it's negative, it moves left, but you have to solve for it first. Okay, so that's the second hardest one to remember. And then the last one has two components to it. A has two things that you have to check. What does A tell me again? Let's go Raf.
How wide it is and whether it's upwards or downwards.
Very good. So wide versus narrow. And it's either upright or inverted. In other words, smiley face versus a frown. Let's recap. Michelle. Oh, actually, you didn't get a note sheet, did you? Oh, you got one. Michelle. How do I know when the graph is wide or narrow? Sorry. But you could refer to those notes. This is just a recap. How do you know if it's wide or narrow?
If it's narrow, it's larger than 1. And if it's wide, it's larger than 0 if it's smaller than 1.
Yes, that's right. Larger than 0 but smaller than 1. So essentially, if it's fractional, it'll be wider than what you normally think. And then if you want it to look thinner, then it's A is greater than 1. So the larger the number, from 3 to 5 to 99, you'll see that the graph kind of looks like it's closing in on the y-axis. But if you put a fraction, so say 1 over 10, it will look wider. And if you do 1 over 100, it gets closer to the x-axis. So if you do 1 over a million, it should start looking like that. So it's really wide, okay? Then you still have A, so that tells you wide or narrow. So the value tells you that. But then what dictates whether it's a smiley face or a frown? Yes, Violet? Very good. Positive. So if you're feeling positive, you smile. So upright looks like this. And then if you're feeling negative, you frown. Now there were specific terms for this type of turning point. I call it smiley face and frown just so it's easier for you to remember. But what's the proper name for the upright shape with the turning point? Andrea? Good. So which one's which?
The maximum is inverted and minimum is upright.
Very good. This is the maximum turning point, TP for turning point, and minimum turning point. Because you can see in the graph it reaches the smallest value you can get, goes back up, and it goes up infinitely. Whereas this one reaches a max value, and then it drops back down. So hence why we call it max turning point and min turning point. Very good. So that's a recap of yesterday's lesson, or whatever our last session was. That was exercise 7A. Now notice down here I wrote, note that the turning point can be found negative HK. Now your textbook teaches you that way. I don't like teaching you that way because it's not always true, especially if there's a number in front of X. That would then not be true. Okay, but the reason why textbooks do that is because a lot of students just look at the letters and they use the inverted sign. Yeah, so if it was +1, they'll say it's -1, meaning going to the left 1. Yeah, so I don't want you to rely on that formula there, but if it helps you to get forward, then that's okay. I actually want you just to read left, right, up, and down. Okay, so let's do an example. I want you to roughly sketch and label the turning point. Okay, so we're gonna, and then after this, I'll show you how to find the y-intercept, which is very similar to chapter 1 that you did at the term 1. But let's start off with this one. I want you to read the graph. So read it. Is it moving up, down, left or right? Is it inverted? Is it normal, narrow, or wide? And I want you to draw a rough estimate over here. Where would the turning point be? What does it roughly look like? And then we'll calculate the y-intercept. I'm going to give you, let's give it 90 seconds. Here we go. Let's see. What does the -9 tell me? Let's go with Rowan. What does the -9 tell me?
It tells us how far up or down it is, and since it's -9, that means it's 9 down.
Beautiful.
Turn point.
9 down because it's -9, and yes, you're correct. That's your k value. Whatever you're subtracting or adding on to the squared function, so it's separate from it, whatever you're adding or subtracting will determine up or down. Whereas what's inside or what you're squaring, this is determining what. Can I please have Jada? What is x minus 4 telling me? So what I'm squaring. Very good. So this is meant to tell you how much it moves left or right, but I showed you a technique. What do you do, Sage?
Let x minus 4 equals 0 and solve for x.
And x equals 2?
4.
4? What does that mean, Lily?
That means it's 4 to the right.
Beautiful. It's positive, so hence it's going to move to the right by 4. Can I get a show of hands who already knew or read that it goes down by 9 and then moves to the right by 4? Hands right up. Beautiful. So if we were to sketch this now, this should tell you where the turning point is. Tells you it goes to the right by 4, down by 9. So starting from the origin, which is 0, it goes across 1, 2, 3, 4. So here's 4. Goes down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So -9 there. So that means the turning point is exactly at 4, -9. This is the turning point. Then you ask yourself, all right, what else am I missing? I need to look for A. What is my A value in this case? Sean?
Solve for A by
What's A? As in it's 1. Very good. So even though you don't see the number, technically there is a 1 multiplied to the quadratic function. Even though you don't write the 1, there's a 1 there. So A is equal to 1. And so what can we say if A is positive 1? There are 2 features to it. Una, name me one.
It's a smile and it's normal.
Okay, very good. So because it's 1, that means when you draw it, you don't have to make it thinner or you don't have to make it look obviously wider. Just draw a parabolic shape. Okay? It's only important, it's especially more important when you have 2 graphs drawn on the same axes that you need to show which one's thinner or wider. But if you're only sketching 1, no one knows whether it's thin, wide, or normal. It's just that if it's very obvious, if they put a 10 in front of the number, you should try to make the graph look thinner. Otherwise, it's not drawn to scale. Okay? So if we were to sort of roughly guess it, you should have got something potentially like this. What's the problem? I don't know where the y-intercept is because there are so many ways to draw it. You could draw it like this. That could have been your normal. Could have been like this. It could have been like this. I have no idea which one of those. But the y-intercept, where it touches the y-axis, it should tell me roughly which one of those would be correct. Because right now this is saying y-intercept is at negative roughly 7, it could be at negative 5, it could be at negative 2, it could have been at 3. I don't know which one. This is why as soon as you can find the y-intercept, it tells you a lot more information about what the parabolic shape should look like. So let's work out the y-intercept now. Back in chapter 1, y-intercept is the coordinate that touches the y-axis. Here's my y-axis, which I'll highlight. There was one key thing about the coordinates on the y-axis that we know. What's so special about the coordinates on the y-axis, Andrea? You make x equal to 0, but the reason why you make x equal to 0 is because all the coordinates that you can think of on the y-axis, let's say this is, I'll draw it again. When that's 1, that's 2, that's 3. If I asked you what the coordinates of these points were, you would have told me 0, 1, 0, 2, 0, 3, and it doesn't matter where I put the point. The obvious thing is x is always 0 on that line. So logically, if I ask you what is the y-intercept of this equation, you don't know where the y coordinate is, but you do know because it sits on the axis, x must be 0. And you're guaranteed that this graph is going to touch. There has to be a coordinate somewhere that actually touches the y-axis. There's no way to draw a parabola without touching the y-axis. That is why we assume there must be a coordinate. So if x is 0 and we want to know what y is, this is where you use algebra and you sub it back in. You say the equation says y is equal to x minus 4 squared minus 9. Since you now know that if it touches the y-axis, the x coordinate has to be 0, well then you've got an equation to actually solve for y, to tell you what the y coordinate is. So it should be whenever 0 minus 4 squared is, take away 9. 0 take away 4 is negative 4. Negative 4 squared gives you 16. 16 minus 9, 7. So that tells me, based on the rule that we've got, to have this graph, x minus 4, to move to the right by 4 and down by 9, when x is 0, meaning when it touches the y-axis, clearly y has to be 7. That's the only way for this rule to work. All right? So if y is 7, that means now, out of all these possibilities, it can't be the negative one, it can't be this one, it can't be that one. The best answer I can get is that 1, 2, 3, 4, 5, 6, 7. This is what your graph should truly look like.
So that's narrow.
Yeah, it's very ugly. But the other thing that I now haven't taught you yet is, well, how do you find the x-axis intercept? Because I don't know how wide it could be. It could actually just be a bit wider. It could be a bit thinner. It could be that way. I don't know yet. But I do know it's symmetrical. The axis of symmetry, when you cut it in half, it's right at x equals 4. But for today's lesson, I only want you to work out y-intercept, label it as 0, 7, and I want you to label the turning point as its coordinates. Okay, we won't work out for the x-intercept yet. You just want to work out for the y and the turning point. Let's try the next one. I'm going to give you now 4 minutes to work out the y-intercept, the turning point, and sketch it more accurately than you did before. So flip over. Let's try this one now. Is it recording? Yes, it's recording. All right, you should have up by 3. Calculate this bit. So x minus 2 equal to 0. You get x equals to positive 2. Therefore, moving to the right by 2. Note, a is negative 1. It's a frown. And it's normal. Y-intercept. We know that the x coordinate has to be 0 on the y-axis. So we calculate 0 minus 2 squared plus 3. Negative of negative 2 squared plus 3, that becomes negative 4 plus 3, negative 1. So you should have a y-intercept at 0, negative 1. Let's go. And we've got to the right by 2, up by 3, and y-intercept at negative 1, 0, negative 1. Something like that. Hands up if you got those points. I want them in coordinates. B. Okay, I want the coordinates. I want to see 2, 3. If you wrote 3, 2, that's wrong. And I want to see 0, negative 1. It has to be not negative 1, 0. Alright, most of us got it right. Alright, last question. Now, using your understanding, thanks, you nines. Thanks, team. The last one, boys, last one is a problem-solving question. So this one, normally in a year 11 textbook, it's the last 2 exercises or so, but I reckon you guys can do this one. This one is just working backwards. So what if I told you turning point now is at 0, negative, sorry, it should be 0, negative 1, and passes through the point 1, 2. Is that a different graph? Oh, there must be 2 questions then, because those 2 don't match. Yeah, those 2 don't match. So, sorry, this should be A. That should be B. So, if this one has a turning point of 0, 1, and it passes 1, 2, are you able to work out the equation for me? So that the parabola has a turning point of 0, 1, but also when you sub in x, which is 1, you get a y value of 2. The second question is, given the graph here, can you tell me what the equation would be? So what should it be?
Is it asking for the whole equation?
Yep, the entire equation. Give me the 2 quadratic equation. If I typed it on Desmos, I should get exactly what you should have there. How do you do it? I'm going to pause the video. Anyone's got an equation? 2 minutes? Okay. Shh, listening. Shh. The key part was the turning point actually tells you a lot of information. Because remember, it's meant to tell you whether it moves left or right, up or down. If you have x is 0, that means you're not moving left or right. The logic is that, even just looking at the graph, the parabola has not shifted left or right. It's only gone up by 1. So just looking at the turning point, the y-coordinates dictate up or down. So it tells you whether you had to go up or down. And the x-coordinate tells you whether you had to go left or right. But since x is 0, it means no left or right. But there's a y-coordinate of 1, so it must have shifted up by 1 because the origin originally started at 0, 0. So that means in your equation, how do you say that you don't move left or right? This has to be 0. So it would be x plus 0 squared, and if you want to move up by 1, k had to be 1. But we don't normally write x plus 0 with a squared there. We might as well just simplify it. It becomes x times x squared plus 1 equals to y. Now from here, we've got k. We know h is 0, but you don't need to write it. We don't have a. That's the parameter. So how do you solve for it? Well, that's why they said it also passes through 1, 2. That tells you that when x is 1, the y value must be 2. For that rule to work, for this rule to work, I need to sub 1 in, and the result has to be 2. So that means I test it. I say, all right, well, let's sub 1, 2. This now becomes 2 equals to a times 1 squared plus 1. And it turns out to be just a times 1 plus 1, and it becomes a plus 1 equals 2. Solve for a, take away 1 on both sides. a equals 1. So that means your equation should have been y equals 2 1 times x squared plus 1, or you might as well just call it x squared plus 1, the way that Sean had said. Okay, so this is called a bit of problem solving, but you're using the information you got, turning point being the biggest giveaway. Then the 1, 2 is just to allow you to find the parameter. I want you to do the same now. Can you do it if I gave you a graph? Instead of a description, I'm giving you a graph now. Have a look at the graph. I want you to be able to tell me an equation that I can type in Desmos, and it should pass through 0, -1, and it should also pass through 1, 1. 0, -1, and 1, 1. Those are my two coordinates. The turning point is key. What's my equation? So I'll change this now. So 0, -1, and we want it to pass through 1, 1.
So is it x squared minus 1?
Already.
All right, let's get a list of potential equations. So you said,
I want to write my
Y equals x squared minus 1.
okay, so we've got one potential one. Let's see if anyone else has a different one.
Wait for mine.
How did we find H in the last one? Left to right. What does H tell us? Wouldn't H be negative?
140.
Wait, what does H tell us?
Because I've got
X plus H. Oh, we substituted X plus H, get it to 0. Yes, that means what's X? Negative 0. X is 1, so H is negative 1. Negative 1 squared minus 1. And then we solve for A. -1.
Is it does trust?
0 minus 1 squared plus. Wait, it's minus 1 because it goes down. So A times y equals 2x squared minus 1.
Ooh, we've got a different. Where is it again?
It's okay. Let's look at this.
Y equals
2x. No, 2x. Is A equal to 2?
like that.
That's what I got. Wait, is A equal to 2? Wait, guys. This is like minus 1. Yeah. You know, yeah. What we do in this situation, just a moment. 0 squared, you get that? Yeah, because 1 plus minus 1. So like the sum of the coordinates. So it should become 3 over A equals 2. Yeah, I thought that's just okay, so y squared minus 1.
Which one are you? Yeah.
Equals 2 bracket x minus 1 squared minus 1.
Like that?
No, we got 2. That's pretty solid. Yeah.
Sean says that's not right.
Get Sean out of here. Stop it, Sean.
Does Sean have his own equation?
Yeah, what's your formula?
Oh, look at this.
Sean just said the second one's right. No! Wait, did you do the second one? Sean's got it. If you've got it, you already know it's right, right?
Most of us are done. All right.
Yeah, please, I want to see this.
Oh, was it recording the whole time? Whoops. That's so funny. All right, let's do. Which one do you want me to do first?
3.
3? All right. Here we go. So we need to cross through this one. So we cross through 1, 1. Let's try it. 2 bracket x minus 1 squared minus 1.
Yeah, we didn't get the turning point.
We've got a turning point. You've got a turning point of moving to the right 1 and then down 1. It's almost like the opposite of that one. That's 1 and 1. But it looks nice there. Let's try the other one. Y equals x squared minus 1. Alright, so Raph has got the turning point correct, but it didn't cross through 1, 1. Let's see if Sean and Ra has got this one correct though.
Of course they did. He's crying out. Why are we even trying this?
Yes, it is. And again, same concept. How do we do this? First thing is turning point.
Because they put the turning point in the wrong thing.
So you read the turning point, it says 0, negative 1. Remember, this determines left or right. This determines up or down. So all of you definitely got the minus 1. That's good. The problem is though, to get left or right of 0, it means that x plus h needs to equal to 0, right? That's normally what we do. But when we solve for x, whatever h is, if it's positive, it goes to the right. If it's negative, it goes left. But what you need is you need h to be 0 for you not to move left or right. So that means we couldn't have minus 1 there. That should have been a 0 there. Okay, so x plus 0 squared minus 1. Now,
You're only one value off.
this is where Raph got that part correct, but then he said A has to be 1, or he didn't calculate for A. It's one or the other.
I did, sir.
You did, so you got A equals 1. So this next bit, how do you find A?
Wait, what? A equals 0.
You sub in the passing point. When x is 1, y needs to be 1. So we know that it passes through 1, 1. So 1 equals A times 1 squared minus 1. A times 1 minus 1. And then that gives you 1 equals A minus 1. If you add 1 on both sides, then you get A equals 2. And that's how you get y equals 2x squared minus 1. Okay, so that was a bit of a problem-solving question, but that's it for 7B.
Can you make another example, please?
Yeah, I can do that.